So another way we can use these formulas is to calculate other pieces of the equation. So, for example, we can look for the future value of the money. We can calculate an interest rate. We can calculate the time that we need to leave the money in an account. They're all just using the same formulas and just solving for different pieces of the formula. So, for example, if you need $5,000 and you can invest your money for 10 years at an interest rate of 5% compounded monthly, how much money should you invest now? So let's say you are, I mean, this is a very simple example, but like if you are planning for the future, you're planning that you need a down payment on a car or a house or something, and you're going to buy that in a couple years, then you can see, is that realistic? Can I save that much money now in order to have that amount, after 5 years or after 10 years? So, this amount might not be what you're looking for, but, like let's say you are saving for the down payment on a house and you need to have at least $20,000, right? And you have some money right now, but is it possible for you to take that amount of money and invest it and earn enough that in that amount of time you'll have the money you need for your down payment? So pretty helpful, right? So we need $5,000, and we have 10 years to get it. So $5,000, that's called the future value. But in our equation, that's just the A, right? That's the final amount that we get, okay? The amount that we need now, that is called the present value. And that's the P in our equation. You can call it the principal, you can call it the present value. Either one, it's the initial amount that you start with, and it is represented by P. Okay, so we know the equation that we're going to use since it says compounded monthly. That's the N equation. Okay, the only equation with N that we had. So N is going to be 12 because it's compounded monthly. All right, the other things that we know are we can invest our money for 10 years, so T is equal to 10. Our interest rate is 5%, so that's R is equal to 0.05. Okay, and it looks like we have everything else listed out. So our equation is A is equal to P times 1 plus R divided by N raised to the NT. Okay, so we have 5,000 equals P, remember we're solving for the present value, P, times 1 plus 0.05 divided by 12 raised to the 12 times 10, because 10 was the number of years. Okay, so you can see that everything that we have in the equation, we have everything except P, okay? So to solve this is pretty simple because we just need to take this into our calculator, 1 plus 0.05 over 12, all raised to the 120. Okay, get that number, and then do 5,000 divided by that number, right? This is actually still just an exponential type problem, no logs involved or anything because we're not solving for something in the exponent. So just get this number and take 5,000 divided by it. So the principal is equal to 3,035.81. Okay, so in other words, we need to have about $3,000 now in order for in 10 years for us to have $5,000. Not too impressive, right? But that is a lump sum of 3,000. We're not putting any more money in, and we're just waiting. And because of the interest in 10 years, we will have, an extra $2,000 for ourselves.